What about the integral of cos cubed x times sine to the power of 10x? What am I going to do this? Well, it turns out you start with a suitable substitution. I'm going to come back to it later. In this case, substitute sine x. Let u equal sine x. Then du dx equals cos x. Now, why did I choose the sine and not the cos to be my u? Again, I'm going to come back to that at the end and help you try to figure that out. So, what happens if I do this? Then my integral becomes, I'm going to get sine to the power of 10x is u to the 10. I want du dx, which is cos x. I've taken one of the cos x's out, so I'm left with cos squared x. So far so good. This one's going to be du dx. What am I going to do with this cos squared? I'm going to leave it for a moment. This becomes du dx dx. But I'm left with cos of an x. I don't want any x's left, I only want u's. But u is sine x, and I can write cos in terms of sine. It's 1 minus sine squared x. Can you see where we're going? 1 minus sine squared is 1 minus u squared, u to the 10, and this is just du. Expand the brackets. That becomes u to the 10 minus u to the 12 du, which is u to the 11 on 11 minus u to the 13 on 13 plus constant. Okay, if I've got that far, substitute back in my u being sine x. And I've got sine to the 11x on 11 minus sine to the 13x on 13 plus a constant. Now, I said I would come back at the end and talk about this substitution that we made. If you have a function like this, involving a power of cos and a power of sine, and one of the powers is odd, it could be both, but if at least one of the powers is odd, then you can use this method successfully. And you use the method successfully if you replace the substitution for the one that's not the odd power. If they're both odd, it doesn't make any difference. But if this one's odd, substitute this one. That will let you solve cos to anything times sine to anything, as long as one of them's odd. What happens if they're both even? Well, it's worth you trying this with two even powers. Just replace with this one with cos to the 4th. Try it and see what happens.